Hello learners, I'm Akash. I completed my BTech from NIT Rourkela in the year 2020. Currently, I'm a mathematics teacher. Now let us see how to solve this given question. Here we need to evaluate integral dx by 1 plus sin x plus cos x. This is an easy question, so it will get over quickly. Now see, take the given integral as I. So I use integral dx by 1 plus sin x plus cos x. Now what I'm going to do is I'm going to make a substitution here. If you'll see, in the denominator I have sine and cos. Whenever there are sine and cos like this in the denominator, how we solve it is we put we put t is tan x by 2. We put t is tan x by 2. Okay. Now what will happen by doing this substitution? You'll see. Now just differentiate both sides here. Okay. Just differentiate both sides. So I'd get dt is nothing but secant square x by 2 into half dx. Now how did I get this? Listen carefully. Listen carefully. Derivative of tan x is secant square x. So derivative of tan x by 2 is secant square x by 2. But it doesn't stop there. In place of x there is x by 2. So I'll get into derivative of x by 2, which is nothing but half dx. Okay. Since I'm just differentiating, I'll get half dx here. Fine. Now next. Secant square x by 2 is nothing but 1 plus tan square x by 2. Okay. And this 2 it's there, right? 1 by 2. The 2 in the 1 by 2. Send it to the LHS. Okay. Now next. Secant square theta is 1 plus tan square theta. So that's why secant square x by 2 is nothing but 1 plus tan square x by 2. All good. Let's go ahead. Now, if you remember, tan x by 2 is nothing but t. So tan square x by 2 would be nothing but t square. So I'd get 2 dt is equal to 1 plus t square dx. Fine. Now send this 1 plus t square to the LHS. If you were to do that, I'd get 2 dt by 1 plus t square is nothing but dx. 2 dt by 1 plus t square is nothing but dx. Fine. So you see I got dx in terms of t totally. Now what about sin x and cos x? See, from trigonometry we have this formula. Sin x is nothing but 2 tan x by 2 by 1 plus tan square x by 2, and cos x is nothing but 1 minus tan square x by 2 by 1 plus tan square x by 2. So in place of tan x by 2 you just need to put t. So sin x is nothing but 2t by 1 plus t square, and cos x is 1 minus t square by 1 plus t square. Fine. Okay. Now all this I'm going to put this in my I. Okay. All of this I'm going to put it in my I. Okay. Now I is nothing but in place of, now in my next step you would see in place of dx there would be 2 dt by 1 plus t square. In place of sin x there is 2t by 1 plus t square, and in place of cos x there is 1 minus t square by 1 plus t square. So this is my I. Now in the denominator I'm going to take LCM. Okay. See, these two terms have 1 plus t square in the denominator, but this term doesn't have any denominator. So if I'll take LCM, I'll get 1 plus t square into 1 here plus 2t, that only 1 into 1 plus t square plus 2t plus 1 minus t square. Okay. Now once LCM is taken, this 1 plus t square and this 1 plus t square, you can cancel them. And now listen carefully. If you see 1 plus t square plus 1 minus t square, t square and minus t square, they would cancel out each other, and 1 plus 1 is 2 and 2t is there in the between. So I'd get 2 dt by 2 plus 2t. Take 2 common from the denominator. So 2 would get cancelled, and I is nothing but integral dt by 1 plus t. Very simple. Integral dx by x is log mod x. So similarly integral dt by 1 plus t is nothing but log mod 1 plus t plus constant. Okay, what is our t? See, in our question they gave it in terms of x. T is something which we brought. So our final answer should be in terms of x. What is t? T is tan x by 2 if you remember in our basic substitution. So I is log mod 1 plus tan x by 2 plus c. I is log mod 1 plus tan x by 2 plus c. Fine. In place of t, I just put tan x by 2. This is my final answer. This is what is there in the textbook as well. Okay. So thank you very much for staying with me up till now. Okay. In case you like this video, please hit the like button. It would encourage me to make many more of such videos. And if this is your first time coming across to my channel, please do subscribe to it. And not just this question, I've made many other questions related to integration, definite integration, differential equation circles, and in 2 as well, binomial theorem and theory of equations. Please do check out the description for further links, or you could go to the playlist section of my channel for some other things which could be useful to you. Okay, fine. Once again, thank you.